Hello and welcome to this video of geometric progression problem number 81 to 90. In this problem, in this slide, we will solve 10 more problems and then we proceed on to next 10 problems. If you have watched my previous videos, then you will notice that this one is different. I'm happy to say that I have changed the default font to Roboto and the math type font is now set to Inconsolata. This makes the slide text look real nice. So let's get started. As always, do not look at the solution immediately. First, you read the problem, then pause the video, and if you cannot solve the problem by yourself, only then you look at the solution. Problem number 81 says that if p of x is equal to 1 plus x square plus x to the power 4 up to x to the power 2n minus 2 divided by 1 plus x square plus up to x to the power n minus 1 is a polynomial in X, then find the possible values of n. So we solve for Px. The numerator is a geometric series with power x with the common ratio x square up to n minus 1 terms. So its sum would be 1 minus x to the power 2n divided by 1 minus x square. The denominator is another geometric series with first term 1 and common ratio x with n minus 1 terms. So its sum would be 1 minus x to the power n divided by 1 minus x. So since it's in the denominator, it is reverse. Now we divide 1 minus x gets cancelled out. So we divide 1 minus x to the power 2n with 1 minus x to the power n. Sorry, it does not get cancelled out. 1 minus x and 1 minus x square will result 1 plus x. So in the numerator we have 1 plus x to the power n, and in denominator we have 1 plus x. Now it is given that Px is a polynomial. That means the polynomial cannot have anything as denominator but 1. Therefore this is equal to 0 must be a root of 1 plus x to the power n, so that x plus 1 gets cancelled. So that means since x plus 1 is a root of 1 plus x to the power n, x is equal to minus 1 should satisfy 1 plus x to the power n is equal to 0. That is 1 plus minus 1 to the power n. We substitute the minus 1 for x. So this is possible only if n is odd. Problem number 82 says that if each term of a GP is twice the terms following it, then find the common ratio of the GP. We let A to be the first term and R to be the common ratio of the GP. And we consider the nth term. So nth term is AN. And the terms following it would be n plus 1h, n plus 2h, and so on. So 2 multiplied by this, where n is an element of natural number set n, capital N. So this is nothing but ar to the power n minus 1 is equal to 2 into ar to the power n plus ar to the power n plus 1 and so on. The sum of this series is nothing but 2 into ar to the power n, because ar to the power n is the first term, divided by 1 minus r, because r is the common ratio and 2 is the prefix. 2 is the multiple of this. So with this and with this, we cancel out ar to the power n minus 1. So here 2r will remain. So here 1 will remain. So 1 is equal to 2r by 1 minus r. Solving this gives us r is equal to 1 by 3. If x is equal to a plus a by r plus a by r square up to infinity, y is equal to b minus b by r plus b by r square minus up to infinity, and z is equal to c plus c by r square plus c by r square up to infinity, then prove that xy divided by z is equal to ab by c. So in this case, x is nothing but a by 1 minus 1 by r. A is the first term, 1 by r is the common 1 by r is the common ratio. So this is nothing but ar by r minus 1. Similarly, we find y to be br by 1 plus r, because common ratio is minus 1 by r and first term is b. Similarly, z is equal to c by 1 minus 1 by r square is equal to cr square by r square minus 1. Now, what is xy? For xy, we multiply this with this to get ab r square divided by r square minus 1. Now we divide xy by z. So we get ab r square by cr square here. R square gets cancelled and the denominator r square minus 1 also gets cancelled. That's why I did not read it out, which is nothing but ab by c. Problem number 84 says that a GP consists of an even number of terms. If the sum of all terms is 5 times the sum of terms occupying odd places, then find the common ratio. So we let a to be the first term and r to be the common ratio. So sum of all terms is a into r to the power n minus 1 divided by r minus 1. Sorry, 1 is missing. Sum of odd terms would be the first term would be a and common ratio will become r square and number of terms would be n minus 2. So the total value of this would be again a into r to the power n minus 1 divided by r square minus 1. Now it is given that s is equal to 5 in times odd sum of odd terms. So a multiplied by r to the power n minus 1, that is s by r minus 1, is equal to s odd, 5 times s odd, that is 5 into a into r to the power n minus 1 by r square minus 1. So a r to the power n minus 1 gets cancelled and r minus 1 gets cancelled with this. So this is nothing but 1 is equal to 5 by r plus 1. Oh, I did not cancel r minus 1. Okay. So in any case, r gives us 4 because r cannot be 1. So we have if we would have cancelled, we would not have got r as a root. You can cancel here r minus 1. There will be no root for 1. If the sum n terms of a GP is 3 minus 3 to the power n plus 1 divided by 4 to the power 2n, then find the common ratio. We let sum of n terms be Sn, which is equal to the given value, be the sum of n terms. Then we find sum of n minus 1 term, n minus 1 terms as 3 minus 3 to the power n divided by 4 to the power 2 into n minus 1. So when we subtract Sn minus 1 from Sn, we get another term, which is nothing but on solving this, we get 13 into 3 to the power n by 4 to the power 2n. So from this, if we substitute n with n minus 1, we get n minus 1th term. Then we divide nth term with n minus 1th term and we get 3 by 16 as the common ratio. In an infinite GP, sorry, this should be dot. I have pressed shift and then pressed it. In an infinite GP whose terms are all positive, the common ratio being less than unity proves that any term greater is equal to less than the sum of all succeeding terms according as the common ratio less than is equal to or half. So we let s be the first term and r a be the first term, should not be s. We let a to be the first term and r to be the common ratio. Then nth term is ar to the power n minus 1. Now sum of succeeding terms, so succeeding terms for Tn would be S infinity minus Sn as we have solved in earlier examples also. This is nothing but a by 1 minus r minus a into 1 minus r to the power n. The n, this n should not be there. It is only r to the power n by 1 minus r. Now we evaluate this to be ar to the power n divided by 1 minus r. Now we equate this with Tn. So we get ar to the power n minus 1 is equal to ar to the power n by 1 minus r, which is equal to 1 is equal to r by 1 minus r. A gets cancelled and n minus powers of r gets cancelled. So 1 is equal to r by 1 minus r. Now we solve this, we get r is equal to half. So this is for equality. Similarly, you can prove for condition of greater than or less than. You can substitute simply here greater than or less than and then evaluate, you will get the result. Problem number 87 says that prove that 666 up to n digits whole square plus 888 up to n digits is equal to 444 up to 2n digits. What we do for the first number is we take out 6 common and multiply with 9. So it becomes 999 up to n digits whole square. A parenthesis is missing here, and a parenthesis is missing here also. From the second number, we take out 8 by n common. So what it becomes is 999 up to n digits. And we take out 4 common from the number, and 9 we multiply with 9. So it becomes 999 up to 2n digits. Now sum of this would be 36 by 81. Now this is 999 up to n digits. We can write it as 10 to the power n minus 1. If you whole square that, you will get 10 to the power 2n minus 2 into 10 to the power n plus 1. And if we write this, then we can rewrite this as 10 to the power n minus 1. So it is 8 by 9 multiplied with 10 to the power n minus 1. So we get 4, and the right hand side we get as 4 by 9 multiplied with 10 to the power 2n minus 1. Now we divide we divide both numerator and denominator with 9. So we get 4 by 9 here, and rest of the terms remain same. Here 4 by 9 means we take 2 inside, so we get this term, which now you see that sum of these two is equal to right hand side. That's how we prove it. Problem number 88 says that find the sum x plus y plus x square plus xy plus y square plus x cube plus x square y plus xy square plus y cube up to n terms. So we multiply and divide by x minus y. It becomes 1 by x minus y multiply with x square minus y square plus x cube minus y cube plus x to the power 4 minus y to the power 4. So you see it is uh, uh, a series which contains two geometric progression, one with x square, x cube, x to the power 4, and another with minus y square, minus y cube, minus y to the power 4. So I have left it up to you to find the final sum, because it is just now applying the formula. Find the sum of the series 4 by 3 plus 10 by n plus 29 by 20. It should be 28, 28 by 27, and so on. So we can rewrite the above series as 3 plus 1 by 3 plus 9 plus 1 by 9 plus 27 plus 1 by 27. Now we divide by 3. It becomes 1 plus 1 by 3 plus 1 plus 1 by 9 plus 1 plus 1 by 27. This should be 27, and so on. So we see that oh, there's a mistake in the final solution. We see that all these ones will become n. Okay, and this 1 by 3 plus 1 by 9 plus 1 by 27, that will become 1 by 3 into 1 by 1 minus 1 by 3. So this becomes 2, and this would be n. So it would be n plus 2. I'll fix this in the slide before uploading it. In a geometric series consisting of positive terms, each term equals the sum of next two terms. Find the common ratio. We let a to be the first term and r to be the common ratio. Then we know that each term is equal to sum of next two terms. So a is equal to ar plus ar square. We cancel out a, and we get the quadratic equation r square plus r minus 1 is equal to 0. So it gives us two values for r. But r cannot be negative because all the terms are positive. It is given here. So r is equal to square root of 5 minus 1 by 2. With this, we come to the end of 90th problem, and in the next slide I will solve 10 more problems. If you have found this video informative and useful, please subscribe to the channel and like the video. It motivates me to make more videos on different topics. Enjoy.